in statistics. For those of you who do not know, this is Dr. Nandi. I frequently lecture on statistics, and I have solved all kinds of math problems, including statistics, algebra, in my channel. So please subscribe to my channel by hitting that subscribe button. And if you like this video, please give me a thumbs up. I really appreciate it. So today the problem we are going to solve is the cost per serving in cents for a sample of cereals rated very good are 1, 2, 3, 4, 5, 6. 6 data points: 46, 49, 62, 41, 19 and 17. 7. The first part is to find the mean. We will be using TI-84. So we are going to use TI-84 calculator. So the first thing we will do is clear the memories of the calculator. Clear the memories. And you do that by this pressing. First you put the calculator on, then press the second button on the top left corner. Second button on the top left corner. Then the plus button. The plus button is on the bottom right. Bottom right. Plus. And then select number 4. So second button, then the plus button, then number 4, which will bring clear all list on your calculator. That means you are clearing the memories of the calculator. Press enter. After clear all list appear on your screen, which should appear when you select number 4. Then you hit enter. Says done. That means the memories are clear now. Or removed all the past work. Okay, now I'm going to enter these 6 data points in L1. So what will I do? I'll press the stat button. Stat button, which is second row. This is in the second row. Second row. And then number 1, which is the edit button. And enter the data in L1. Enter the data in L1. L stands for list 1. L1 is list 1. All the 6 data points. So you type one after another in the same column L1. 46 and then enter. 49 and then enter. 62, enter. 41, enter. 19, enter. And 76, enter. So I have entered the 6 data points in L1. Now I am ready to do the calculation. I will again press the stat button. Okay, then I will highlight, means on the top row, move the cursor, the black rectangle, move it to calc from edit. Calc. On the top row, the cursor should move to calc. Then select number 1, which is 1 where is the short of variable stats. So we are selecting number 1 and press enter. 1 where stats. The first line is list. It's already set at L1. We do nothing. Okay. Then we go all the way down to calc. Do not do anything in the second line. Go all the way down to calculate. Put the cursor. Cursor is a black rectangle on top of calculate and hit enter. So let's write down the answers. Some of the answers. The mean is the first line. Okay, X bar is your mean. Okay, the mean is the first line. X bar is equal to 49. This is X bar, which is sample mean. Okay. We are now looking for median. To get to median, we have to scroll down to the first line in this next screen, which is MED. MED stands for median, and that is equal to 47.5. Okay, so median is the 50th percentile. What does it mean? 50% of the numbers below 47.5 and 50% above 47.5. Notice mean is slightly greater than, mean is 49, right? Mean is slightly greater than median. When this is the case, it is skewed to the right. Why, you ask me? Because there is some high number in the data set which pulls the data towards it, skewed to the right or positively skewed. Positively skewed, because the mean is greater than the median. The mean is 49, the median is 47.5. So we have answered mean, median, skew of the data set. Now we are interested in standard deviation. Since this is sample, Sx is the sample standard deviation. Sample standard deviation. And Sx is equal to, it's on your calculator screen. If you look carefully, it is 19.63. How many places should I go? Usually 2 or 3 places. Here it is 19.63. That is your standard deviation. What does it mean? It's an average variation from the mean. From the mean. Or average deviation, difference from the mean. Variation from the mean. That's what standard deviation is all about. In this case, it's 19.63. Next is interquartile range. IQR stands for interquartile range. Interquartile range. It is the range of the middle 50% of the data. Range of middle 50% of the data. Middle 50% of the data. And in this case, IQR is third quartile minus the first quartile. Okay, and that is equal to, we already noticed Q1 is 41, but let's write Q3 minus Q1. So Q3 is 62 and Q1 is 41. 62 minus 41 is 21, is the interquartile range. So 21 is your IQR. Now we have to find out any outlier in the data set, and we draw a lower outlier boundary, construct a lower outlier boundary. If there is any number less than the lower outlier boundary, then it is an outlier. Any number less than the lower outlier boundary, which is Q1 minus 1.5 IQR. In our case, it will be Q1. What is our Q1? Our Q1 is 41 minus 1.5 times 21, and that will be a negative value. So it is 41 is Q1 minus 1.5 times difference between Q3 and Q1. So that answer is 41 minus 1.5 times IQR is 21, and that is 9.5 actually. Is there any number less than 9.5 in the data set? No. Okay. No number less than 9.5 in the data set. Conclusion, no outlier on the left. How about any outlier on the right? Okay, so we do the upper outlier boundary. Which is upper outlier boundary, which is Q3 plus 1.5 times IQR. So in our case, this is 62 plus 1.5 times 21, which is, let's do the calculation, 62 plus 1.5 times 21 is 93.5, okay, equal to 93.5. No number greater than 93.5 in the data set. Highest number in the data set is 77. Okay, that is not greater than 93 point. So no outlier. So basically there is no outlier in this data set. So let me review what we did. We entered the data in L1, then we did stat calc number 1 where stats list is L1, got the mean x bar, sample mean is 49, got the median which is MED 47.5, mean is greater than the median, is slightly skewed to the right or positively skewed. Sx is the sample standard deviation is 19.63. What does sample standard deviation mean? It's an average variation or deviation from the mean. Then we calculated the interquartile range. It is the range of the middle 50% of the data. Remember, Q3 is the third quartile, 75th percentile, and Q1 is the first quartile, 25th percentile. 75 minus 25 is the middle 50%, and that is works out to 62 minus 41 is 21. Okay, so that's your interquartile range. Now we need to find outliers. We have to construct a lower outlier boundary and an upper outlier boundary. What is the lower outlier boundary? The formula for it is Q1 minus 1.5 IQR, which works out to 9.5. Our lowest data set is 19 and 77 is the highest. So no number less than 9.5 in our data set, no outlier on the left. Similarly, if we do the upper outlier boundary calculation, which is Q3 plus 1.5 IQR, it works out to be 93.5. However, our largest data point is 77, which is less than 93.5. Therefore, we have no outlier on the left or on the right in the data set. And that is the solution to this problem. I'll stop here today. If you have any question, do not hesitate to shoot me a question. Write me a comment. I'll get back to you as soon as possible. I will answer each and every one of your questions. If you like this video, please give me a thumbs up. It really motivates me to produce more interesting videos just for you. If you like my video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button. And please do not forget to click on the notify button, which is the bell button, which will inform you every time I upload a new video. And also, please let me know in your comment where you're watching from. What is your time right now? I really appreciate that. And I appreciate the fact that you took time to watch my video, and please do not forget to watch me again tomorrow when I'll be back, promise, with another interesting video. Thanks for watching. Take care. Have a great day. Take care.